Hello, my name's Glenn Vickery and welcome to my YouTube channel Kiwi Bushcraft and Survival. And today I thought we would go into a bit of land navigation. Okay, and the first thing we would need to do when we're learning this is talk about maps. Okay, so with maps, I think everybody knows what a map is generally. Everybody's probably seen a road map. Okay. That you use when you're in your car to find out where you are. Road maps are quite easy because you've got like signs on the roads that will tell you the name of the road, and you can find your way around quite easily. You don't need a compass or anything else like that generally. You can find your way around quite easily. There's other kind of maps like Google Maps. A lot of people have Google Maps on their phone or on the computer. And you can find your way around by using Google Maps. The type of maps that we're going to get into are what we call topographical maps, and these type of maps are generally used for land navigation when you're out bush bashing it. So you're either out on carrying your pack, or you're going for a day walk in the mountains or the hills. Or you might be in a jungle or a forest or something along those lines. Okay, so when you're out in the wop-wops, the type of map you want to be using generally, we use things called a topographical map. Now there's let's get straight into it and have a look at it. Okay, now this here is a what we call a topographical map. Okay, just there. Right, you may or may not have seen this type of map before. Okay, what is a map? Okay, basically a map is a bird's eye view of a portion of the world's surface. Okay, all right, so you can imagine a bird flying above the land here, okay, looking down. And that's what a bird is going to see. Or you can imagine yourself flying in a plane and you're looking down and you can see a portion of the Earth's surface, the land below you, and this is what it's going to look like. Okay? And so what's happened here is the map has had a photo taken of a portion of the Earth's surface, and it's been put in a picture form on a piece of paper, okay, where we can use this to navigate on land. Okay, so that's basically what it is. Alright, so if I grabbed, just in a little bit more detail, if I grabbed a globe here of the world, okay, here we are down here in New Zealand, down at the bottom of the world. Okay, and basically if I was flying over this here, or a bird was flying over this, over the land, looking down, and whatever the bird could see, a portion of that land or that earth, this is what we would see on the map. Okay, now the world as we see it is round. Okay, it's a big globe, it's like a big ball, so it's sort of round, and the map is not round, it's flat. So the map will be slightly distorted, okay, because the map is a picture of what's come off the actual planet. Okay, now the planet is round, it has a curvature, okay, it's not flat. And so the map is the closest that we can get to making it flat on a flat piece of paper compared to what is actually on the ground itself. Okay, so that's a map. Let's have a look at some of the portions of the map. Or let's talk about the map in general first. Okay, now the map itself here that we can see points north. Okay, so the top of the map up this end here where my hand is, okay, this is the north. okay, which is pointing towards the top of the Earth, the top of the globe. Okay, so if you can imagine going back to our globe here, okay, the map, all maps point to north. The top of the map points to the top of the world, okay, and the bottom of the map points to the bottom of the world, and the right hand side of the map points out to the east, okay, and the left hand side of the map points out to the west. Alright, so in this case with the map here, as I said, where my pencil is pointing and going towards the top of the map up here, that's the north, pointing towards the top of the globe, top of the world, and out to the right hand side where I'm pointing now, okay, out on this side where my hand is, that is pointing to the east, okay, and at the bottom of the map down here, pointing down this way, is south, pointing down towards the South Pole, and out to this way here, out on the left hand side of the map, is pointing to the west of the globe. Okay, so all maps come pointing with the top of the map pointing to the north. Okay, so that's very important. Okay, what is particularly important about a topographical map? Okay, a topographical map is basically very important in the fact that it's generally focused towards bush areas. Okay, if you're going out in the bush, if you're going out in the mountains, in the jungle, things like that, where you're going away from a lot of roads and things like that, you're going up into the mountains. Okay, you're going hiking, you're going camping, you're going hunting, or you're using it for military operations and things like that. Okay, so it's used for going out in the wops. Okay, what makes it particularly important is it is used. The topographical maps have grid squares on them. Okay, so what I mean by grid squares is, if I can, I'll bring the map up a bit and see if we can get a picture of it. I don't know if it's going to munt out on us. Okay, see if we go. Alright, so if you can see all the lines here, see the blue line, and there's another blue line over here, and another one over here, and another one here, and then there's also lines that go across. A straight line that goes across, and another straight line here that goes across. Okay, these here are all called grid lines. Okay, and what these grid lines do, okay, they split the whole map up, okay, into sections. Okay, what we call grid squares. Okay, and so each square that you can see here, okay, if you can get that square there, I'll get a pointer. Let me get a pointer. Okay, so if you can see the square here, okay, that there is called a grid square. Alright, a grid square. And so you've got hundreds of grid squares on the map. Okay, and it sections off the map. Okay. That's what we have on topographical maps. Another thing that we have on topographical maps is things that we call contour lines. Okay, I'll try and get in here. And you can see, if I can get it in here. Where are we? Yeah. See if we can find some good contour lines. You can see all these orange lines here. See these orange lines, these wiggly orange lines? These are what we call contour lines, and they give us the heights of the land. Okay, so they give us the elevation of the land itself, and the shape of these contour lines tells us the shape of the land. Okay, so if you can see this one here, okay, that's telling us the shape of this hill. Okay, the other contours that are going around it here are telling us the shape of the land. So the contour lines are extremely important on a topographical map because they tell us the shape of the land. So by looking at the map and looking at the contour lines, okay, it will tell us what the land looks like. Okay, so that's very, very important for a topographical map. Okay. Other parts of the topographical map that are very important is, let's start from the top of the map here. So we have what we call the marginal, so the part over here that I just showed you, that's the main part of the map. The other part of the map is what we call the marginal information. Okay, so if you see where my pencil is here, all this area here is all part of the margin. Okay, and coming out along the bottom of the map here also is all part of the margin. And within the margin, all along here and up the side, is all what we call marginal information. And that marginal information, all the information in here, will help us to use the map. Okay, and all of the information that's contained in the marginal information is extremely important when we're using the map. Okay, so let's start at the top of the margin itself. Okay, what do we have? Let's bring this up a little bit closer. Okay, the first thing we have, I'll just fold this up a bit, make it a little bit easier to use. The first thing we have when we're dealing with marginal information is what we call the legend. Okay, and the legend, I'll just fold this up a little bit more actually. Okay, that's better. Okay, so the legend will tell us things like, this part here is, say, roads and tracks, and it will give us a diagram, okay, a symbol of what the roads look like that are on the map. Okay, so for example, this one here is a state highway, so it's a main highway, and it's State Highway 1 in this case. It might be State Highway 2, State Highway 4, State Highway 20, whatever it may be. Then it will go down into other roads, which is like another main road here. Okay, and then it goes down into smaller roads, tracks, okay, vehicle tracks and walking tracks. Okay, it'll go into sealed roads, tar sealed, unsealed roads, and things like that as well. Alright, let's moving on down. It's going on to hear about railways, so railway lines, okay, here's railway junctions, and whatnot, okay, railway crossings, things like that. Then in this case here, we're going into things that we would call just miscellaneous. Alright, miscellaneous, okay, and here we're talking about residential areas, which is things like where there's buildings, and you can see all the grey area here around the road, so that's a residential area where people live, okay, and there's buildings, factories, things like that. Okay, large buildings would be the big black boxes, okay, for large buildings. We'll carry on down because I'm not going to go through all of them. What else we got here? Just I'm just trying to have a look at the same time. Okay, so we've got churches, cemetery, grave, training track for like a race course, for like horses and stuff like that. So it goes into all these different symbols and whatnot. Okay, shipwrecks, pipelines underground, and blah blah blah. Okay, then we're going into things like telephone lines, okay, and things like that. Let's flick it down a little bit further, and we're going into relief things. So we're talking about contour lines, which is what I talked about before, which has got the little orange lines, wiggly lines, and these contour lines are probably one of the most important things, and they will tell us the shape of the land. By the shape of the contours will tell us the shape of the land. And this particular map, it shows us that the contours actually go up in 20 metre increments. Okay, so it's in metres. Alright, so that's quite important as well. So in between each contour line would be 20 metres. Okay, it goes into other things like might be ice and different things like spot height, spot features and trigs and blah blah blah. Okay, carry on. Now moving on down, it's going into some water features which are in blue. Alright, and it might go into things like estuaries and shoals and reefs and boat ramps and whatever else, marshland and swamp and all that kind of stuff. Okay, and streams, going into like little blue lines for streams and water tanks and whatever else. Okay, it's just giving you an idea. And then we're going into things like here vegetation features, which is talking about like native forest, which is like the dark green, very close together. Okay, so it'll be quite thick area to walk through. Then we've got exotic coniferous forest, which is probably talking about, you know, things like pine trees and stuff like that. And then here you've got exotic non-coniferous, if I'm pronouncing it wrong, who cares? Okay, forest, which is things that bush areas that are not pine trees and stuff like that. Okay, then you've got shrubland and just other trees, and as things go from dark to lighter, that means the lighter it is, the easier going it is. So that's very important when you're using maps. And then it's got mangroves and things like that, so you don't want to be walking through the mangroves. It'll be really hard work. So the legend, it gives us a diagram of what's on the map, and then it gives us it tells us what that diagram is. So the legend is extremely important when reading the map. Anything that you find within the map here, symbols and things like that, if you're not quite sure what it is, you come over to the legend, you go through the legend, you find it, and you'll know exactly what you're going to be coming across, what you're going to be looking at on the map, and that will be what's on the ground. Okay, moving down the marginal information, we have a part here, and every map has different marginal information, by the way. They're not all exactly the same. Okay, so in this case here we have what we call important information. Important information will generally talk about things that how the map is not 100% accurate. Okay, for example, the representation of the map of a road or a track does not necessarily indicate public right of access. So just because you see a road or an area or a fence or a gate or something, doesn't mean you can necessarily go on it. It might be private land. Okay, so that's very important. Other things that it can go into is it can talk about things like that the map is not, depending on when the map was made. This map I've got here is very new. It was actually published in 2015. All right, published in 2015. So it's only a couple of years old. So this map will be very accurate. Okay, so important information will talk about things like if the map was made 30 years ago, then the land may have changed on the map. Okay, so let's take for example these creeks here. Okay, let's take for example, let's say for instance that this stream here. Imagine somebody put a dam further up the stream, and this stream no longer existed. Okay, the stream may not be there anymore in say 20 years time. Somebody might have put a dam up further up and the stream's gone. So it'll show that there's a stream on the map, and there currently will be a stream there, but at some stage someone might dam it up. Okay, it might show certain features like hills or whatever. Okay, so imagine these contour lines here. Imagine this feature here. All right, and imagine there was really bad weather, a lot of rain, and half of that feature came down. Okay, it just crashed. All right, came down, came apart, fell apart. Might be an earthquake, whatever. And that feature there, so when we look at the contour, it's going to tell us how what the feature looks like, what the land looks like. That may change from an earthquake. It may change from erosion, from lots of rain and bad weather and things like that. Also, the sea, we don't have any ocean on this particular map, but if the sea's hitting the land, it can erode the land and change the layout of the land. So the map, okay, when we're looking in the important information, will normally tell us that the map is only as accurate as since when it was taken, okay? So it was taken 2 years ago, this particular map, which means that the information on it will be pretty accurate. If the map was published or made 30 years ago, then some of it may not be 100%, okay? I would say it would be pretty accurate, but it may not be 100%. If the map was made 100 years ago, chances are there's going to be erosion, would have been earthquakes, there would have been, the land's going to change, streams might have disappeared through farming, whatever, okay, and things like that. So we need to take that into account, and you'll normally find that kind of stuff in the important information. Okay, this type of map here is called a NZ Topo 50 map, okay? So basically a Topo 50. The NZ in this case just stands for New Zealand, which is where I am. The Topo 50 is a short form for topo, meaning topographical, and 50 means that the map is a 1 in 50,000 map, okay? So if I scroll down just a little bit further, you'll see here the title of the map. So in this case, this map is a Topo 50, right, which means it's a 1 in 50,000 map. Okay, so that means for every 1 centimetre, okay, I might going off my memory, for every 1 centimetre on the ground, okay, or on the map, should I say, so one centimetre on the map here, imagine my, from the tip of the pencil here to where my thumb is 1 centimetre. 1 centimetre on the map here is actually 50,000 centimetres on the actual ground. Okay, so it might only look like a very small distance here, but 50,000 centimetres is quite a fair way. Okay, so basically 1 centimetre would be, I would say 500 metres on the ground, okay, if we're talking metres. So we have the 1 in 50,000, so that's our Topo 50 map, or 1 in 50,000, okay, 1 in 50 otherwise. We have the title of the map, okay, and we also have a thing here called BF34. Now the BF34 is the number of the map. So every map, okay, every topographical map is numbered, okay, and the reason why it's numbered, if you can imagine, let's going to go to the map here, just up above on the legend. If you have a look at, we've got a picture here in the legend of the North Island of New Zealand, okay, and you'll see a little orange or red rectangle here, and that little rectangle is this map, okay, is this map here. It's the map, this map is the area of that little rectangle there of New Zealand, okay, so it tells us where we are. Alright, so, and obviously as I said before, the top of this rectangle, the top of it is facing north, pointing towards north, towards the top of the world, and the bottom of that rectangle is pointing towards south, and the right hand side is pointing towards the east, okay, and the left hand side of that rectangle is pointing to the west. Moving on down, we can see here what we call adjoining maps. So as I said before, this map is the New Zealand Topo 50 BF 34, and if we come down here, we can see this little orange or red rectangle, and it has BF 34 Bennydale in it. So this part here is the actual portion of this whole map here, alright, on this map. And we have adjoining, again, that BF 34 is over here, the BF34 on the actual country. We have adjoining maps. So we've got BF34 here. On the right, or the eastern side of the map, is BF35, and it will also tell us the name of the map, Whakamaru. And on the left-hand side, we have BF33, Tikuiri. And then if we go to the northern side of the adjoining map, to the north, we have BE34, and so on, BE35, BE33. Coming down to the south side of the map, okay, is BG34, and to the right BG35 and BG33 over here. So this will tell us our adjoining maps, okay. So if you wanted to travel from this map here and head over into this direction, you would need to get this map. So you could order this map here if you knew that you were going to be going from here in this direction, going off BF34 into BF35. Okay, so that's what we call adjoining maps. Okay, the land information here. Okay, this is just where we can get our maps from them. Okay, so if you wanted to order a map, you can contact these guys and get a map, or there's other places you can get maps around the country. The next thing we're looking at on our map here is what we call the magnetic declination. Okay, the magnetic declination. And for most New Zealand maps, okay, all of these magnetic declinations are slightly different. In this case here, this one has the first arrow pointing directly up, all right, going towards the north of the map. Okay, if we look at it like that, okay, it's pointing to the north, and that one there is called grid north. Okay, you can see it here. I'll bring it in closer. Grid north. So that's the grid north arrow, and out to the right hand side we have the magnetic north arrow pointing out to the right, because this map is basically saying that your compass, your magnetic compass, so everybody knows that a magnetic compass, the compass points north. Okay, the magnetic needle points north, and this arrow shows us the direction that the compass will be pointing when using this map. Okay, so when using the map going straight up and down, the magnetic compass needle will point out to the right with this map, okay, on this part of the country. All right, and with the magnetic declination, I'll get into it in more detail at some point. All right, and in between these two arrows, okay, we have what we call the grid magnetic angle, or the GM angle. Okay, and we don't need to worry too much about that right now. Underneath the magnetic diagram here, the magnetic declination diagram, we have some information. So let's quickly just read that out. Magnetic north, which is this arrow, okay, magnetic north on this map is 22 degrees, okay, or 391 mils east, okay, which is east, which is to the right, okay, east of grid north. Grid north is straight up and down, so again, magnetic north, okay, is east to the right of grid north, which is straight up and down, okay, on the map. Okay, east of grid north during 2015, okay, which the map was made 2015, increasing, okay, that's the magnetic, this arrow here will increase, which means it'll continue to tick over to the right. Okay, it's going to increase at the rate of approximately half a degree, all right, or 9 mils over 25 years. So when you see the mils, the degrees here, most people understand that most civilian compasses work in degrees, okay, from 0 right round to 360 degrees. With military compasses, a lot, not all military, but a lot of military compasses use mils, okay? which is, in this case here, 22 degrees is equal to 391 mils. Okay, so a military compass would use normally mils, and a civilian compass would use degrees. And down here, the change of the magnetic north, okay, the magnetic arrow here, okay, changes half a degree over 25 years. Okay, or 9 mils, changes 9 mils over 25 years. And we'll get into that in more detail another time, okay? But this diagram and this information is extremely important when you use a map and a compass together, okay? We must learn how to use this. And for those that are interested in that, I will go into teaching you how to use this in order to use a map with a compass. Okay, so a map can be used by itself, or it can be used with a compass. Further along the marginal information here, I'm just going to put that down. Okay, further along here we have the scale, okay, of the actual map itself. And as we talked about before, it's a 1 in 50,000 scale. So for every 1 centimetre on the map is 50,000 centimetres on the ground, which is basically, for every 1 centimetre, it's 500 metres on the ground. Okay, so if I do 1 centimetre on the map, that's actually 500 metres on the actual ground, on the actual land itself. Okay, the vertical interval between the contours is 20 metres. That's very important information. Okay, so just really quickly, I'll give an example of what that's talking about on my brand new whiteboard, okay, which I bought especially for you guys, okay, to help teach you some of this land navigation. So that, where it says the vertical interval between the contours is 20 metres, what this means is, if you remember when I talked about the contour lines, okay, that's those squiggly lines that show us a hill, okay, and let's say we've got another contour line here, and another contour line here, and another contour line here, okay, that would be showing us maybe a hill. If we do the side, this is looking down on a mountain, for example, or a hill, from a bird's eye view on the map. And each one of these lines is called a contour line. Okay, so what I'm going to do now is I'll sort of do like a picture of what maybe this might look like. We'll do another contour here and another contour there. So let's have a look at this. This might actually look something like this. Okay, so the actual mountain, looking at it like this, is what that looks like for the contour lines. And so these contour lines here would be going along, say, like that. All right. How many we got? One would be the top here. All right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, now these would be all even. I'll try and make them as even as I possibly can. Okay, so those are our contour lines. So if you can imagine that those are our contour lines there. I'll zoom it in a little bit better. I reckon we can get in a little bit better. Okay, so these are our contour lines. So if imagine that this is going down like that. Okay, that one's probably coming down to about there, to about there, to about there, and to about there. Alright, and same along here. These are going to about that, that's going to about that, that one's going to about that, that one's going to about that, and that's going to about that. Okay, so this is what the contour lines look like, and that's what the feature would look like if we're looking at it from an angle, from the side on, and that's from top on. So that's from the top, and that's from the side. All right, and our contour lines will tell us that. Now, when we said just earlier that the vertical lines of the contours are 20 meters apart. So let's imagine that this contour line here was at 20, right? That would be 20 meters, okay? It won't have the M, it'll just show 20. But in this case, I'm just going to put the M there, right? Actually, I'll take it away, right? So that there is 20 meters. The next contour up, this one, the one on the inside here, would be 40. Right, that's 40 meters, right, above sea level. And the next one here is going to be 60 meters above sea level. The next line would be 80 meters above sea level. And the ones on the top here, I'm not going to write them in, but they would be, as you know, 100 meters above sea level. Okay, so each contour, as it's going up, is showing us that at the bottom here, that's the bottom of the mountain, the hill, and then it's going up to 80 meters and 100 meters being the top. So again here would be, if we drew this out, we came out this way, that would be 100 meters. This one here would be 80 meters. This one here would be 60 meters. That one there would be 40 meters. And the one at the bottom would be our 20 meters. And obviously this one in here would be our 100 meters, but I'm not going to write it in. But we know it would be 100 meters because it's the next contour line in. And this is why, as I said earlier, that the topographical map, one of the most important parts on the topographical map is our contour lines, okay? Contour, hopefully I'm spelling it correctly, lines, okay? Our contour lines, right? That's these things here. And the colour of those is brown, okay? A light brown colour or a light orange colour. Depends on what sort of colours you see, okay? So that's very important. And so, as we just seen just a minute ago, all right, the map tells us exactly what scale the contour lines are. Okay, let's zoom that in. All right, so the vertical interval, or the distance, the gap, all right, vertical would be straight up, all right, so going from bottom to top, okay, or just in between each line, okay, the vertical interval between the contour lines, or between the contours, is 20 meters. So that's very important information. Not every map is the same. A map may do it in 10 meter intervals, it may do it in 40 meter intervals, it may do it in whatever, okay, it may do it in feet, it may do it in something else, okay, some other measurement. Alright, so that's very important. We'll find that in the marginal information. Okay, in New Zealand, pretty much all contour lines are done in 20 metre increments. Okay, the next thing that we will find below, sorry about that, the next thing we'll find below this is what we call a scale. Okay, and this scale here, okay, we'll try and zoom it in down here. Okay, you'll see here it's got 0, right, and then it goes out to 1, and it does that. It's showing in between here 20 meters, right, 20, so it'll be 0, 20, 40, hang on, 10, will be 10s, sorry. Hang on, so it'll be 1, 2, 3, 4, 5. So from 0 to that first one would be 100 metres. Okay, all right, on the actual map, it's 100 metres. So 0, 100 metres, 200 metres, 300 metres, 400 metres, and the small line near, slightly larger line, is 500 metres. So between 0 and that line there is 500 metres. If we carry on, 600 metres, 700 metres, 800 metres, 900 metres, and 1 kilometre, or otherwise known as 1k. Okay, 1k is just short for saying 1 kilometre. Okay, if we look out to the right, that 0 goes 0, 1, so that's 1 kilometre, 2 kilometres, 3 kilometres, okay, going along 4 kilometres, 4, 5, 6 kilometres, coming along 7, 8, 9, and 10 kilometres. Okay, and you can see clearly it tells us 10 kilometres. So this scale, what we call a scale, we can use that when we are measuring things on the map itself. Okay, we can use the scale here. Each grid square, okay, if we go into the grid squares, come down a bit. Okay, if we see the lines here, right, you can see there's a square here, right, the blue line. That there is called a grid square, okay, and the grid square is 1 kilometre. From that corner to that corner is 1 kilometre, and then going from the corner to corner down is another kilometre, and then going from that corner to that corner is a kilometre, that corner to that corner is a kilometre, that corner to that corner is a kilometre, or basically 1k from there to there, 1k from there to there, 1k from there to there, and 1k from there to there. So this square, or what we call a grid square, is 1 kilometre squared. Okay, so it's a kilometre on each side, which is, as we just seen on the scale here, okay, 1 kilometre. Alright, so each grid square is 1 kilometre to the bottom, 1 kilometre on the left, 1 kilometre on the top, and 1 kilometre on the right. So every grid square is 1 kilometre, each side is a kilometre, alright, or 1k. Okay, what else do we have here? Some more very important information is the horizontal datum, okay, of the horizontal datum here of this map is datum 2000, or otherwise known as NZGD, okay, for New Zealand Geodetic Datum 2000. Okay, so this is a late model map. Okay, it's a modern map, and the NZGD 2000, in this case, for all purposes, or for practical purposes, NZGD 2000, or New Zealand Geodetic Datum 2000, equals WGS 84. Okay, so WGS 84, alright, I'll try and zoom it in there a little bit. The WGS 84 here is the latest, one of the latest types of datum that we use for maps. And these here are used for when we are using a map with a GPS unit, okay, a satellite positioning unit. Okay, so if you know what a GPS is, it's a global positioning system, and a GPS is like a handheld unit that you can use to find where you are on the ground. This map here, you would use this map with all the grid lines. Let's come back a bit, because this is about something similar and about the same. All the grid lines that we see that this map is broken down into, all the lines, and all the lines are going straight up and down and to the left and right, creating all those squares, which we call grid squares. When the map is broken up like that, that's what we call the UTM. Okay, and the UTM is, if I remember right, is the Universal Traverse something. Okay, I can't remember exactly, but UTM is the method of breaking the Earth up into grid squares. Okay, and so that's what the topographical map uses. It uses UTM, otherwise known sometimes as UTM ups. Okay, UTM ups. Alright, so I'll write that over here. So the grid squares, all the grid squares on the map, all the lines going up and down and to the cross like that, the powers to be that be used a thing called a system called UTM. Okay, UTM. And that's basically breaking all the world up, all the land, into grid squares. Okay? And they've done that all over the world, all over the entire globe. And so when you see these grid squares on the, these lines on the map, the topographical map, that's part of what we call the UTM system. Okay, the UTM system. Okay? And when you use the map with a GPS unit, you're using the UTM as well as what I just explained there, which was the NZ Geodetic Datum 2000, okay, or otherwise known as WGS, I think it's WGS or WSG, WGS 84, okay, 84, right? So the NZGD 2000 is the same as, for practical purposes, WGS 84, alright? And so what you would type into your GPS unit, modern day GPS unit, it would be UTM, and the geodetic datum would be either NZGD 2000 or WGS 84. Okay, and so if you see the WGS 84, use that one. Alright, you can't go wrong with using either. Okay, so those are very important if you're going to be using a map, this map in particular, this map with a GPS. Okay, so that's very important for those of you that use GPS. Okay, then we go into the next one down, okay, on the information, marginal information here, and it talks about the projection, New Zealand Traverse Mercator 2000. We don't need to worry too much about that, okay? It's just talking about the projection of the map, how the map was made, okay? Part of how the map was made. It's not going to make any difference to us, all right? Then it goes into a few other things here, GRS 80, some scales, latitudes and longitudes and blah, blah, blah. Not too much of a major for us, okay? We don't need to worry too much about that. Then we go into it's copyrighted, and then over to the left hand side of the margin we have what we call the grid reference, to give a grid reference on this map. Okay, we're not going to do grid references at the moment on this map. A grid reference basically is giving a location of where you are on the map or giving a location of a place on this map, and that's all a grid references. And we'll go into grid references on another video, so I don't want to make this video too long. I want to go into as much detail as possible, but I don't want to go into it in too much depth. Okay, now there's probably apart from the grid reference system, it's got it all on here. It actually explains how to find your location, what numbers we use to find your location on the map or give your location to someone on the map. That's all this does, and it tells you, breaks it down and tells you how to do it. Okay. What else? The last thing I really want to go into of what we have on the map here is what we call eastings and northings. Okay. Now on the map here, I'm just going to scroll back a little bit. On the map, along the bottom of the map here, we have what we call numbers. Okay, so we've got a number here, a number at each line where there's all these lines going straight up and down. The lines that go straight up and down on the map, the blue lines that I was showing you, okay, all part of this UTM system, all these lines, all the lines that go straight up from south to north, okay, from south to north, or if you want to look at it from north to south, the ones that are vertical, the ones going straight up and down here, all of them, all along here, those are called eastings. Alright? They're called eastings. We call them eastings, and it's quite important that you remember this. Okay, so all the lines going straight up and down, okay, the blue lines are called eastings, and they start at the bottom of the map and they go right to the top of the map. Okay, so they start at the bottom of the map here and they go all the way up in a straight line right to the top of the map. Those are called eastings. Alright, let's bring that back a bit. Okay, now the lines are called eastings, but the numbers at the bottom of each of those lines, okay, down here, all the numbers that go along, these numbers are numbered from left to right, okay, and these numbers are the numbering the easting lines, the lines that are going straight up and down. These are the numbers for them. Alright, now these numbers will always increase by number. So for example, this number here is number, let me look at it closely, number 5. Okay, so 05, 06, 07, 08, 09, 10, 11, 12, 13, 14, 15, 16, 17, and so on. Up to, we have 27 there and 28 on the end. Okay, and so these numbers are the eastings, the easting numbers. So they go from left to right, but the lines themselves go from north to south. But the numbers are called, these numbers at the bottom going from left to right are called eastings. Why are they called eastings? Because they go from here out to the eastern side of the map, out to the eastern side of the map, out to the right hand side of the map. Okay, so these numbers are called eastings, and the lines that are connected to them run from south to north, okay, up the map. Very important. Okay, because these numbers we're going to be using at some point to do our grid reference system, okay, to find our locations on the map. All right. The next lot of numbers that are extremely important as well are these numbers on the left hand side of the map. Okay, and these numbers here are called northings. Okay, and they're called northings because they go from south to north, the numbers. Okay, and so they start off here at number 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, and they carry on up to the top of the map. Okay, And so again, these numbers always increase, okay? They always go up, increase as they go up from the bottom of the map up to the top of the map. They increase in value, all right? So they're going from 31, 32, 33, 34, 35, 36, 37, 38, and so on. They never go backwards. They never go 31, 30, 29, 28. They don't go down. They always go, as they're going up north, towards the north, they always increase in value. Okay, so that's very important. Now, attached to these numbers, to these northing numbers, is these lines that run from horizontal, that run from west to east. Okay, all these vertical, should I say horizontal lines that go along the map this way, okay, they are all attached to these northings. So the lines that go left to right, okay, or right to left, however you want to look at it, the ones that are horizontal, okay, are all connected to these northing numbers. All right. So I'll try and bring the map in a little bit so that you can hopefully see some of these numbers a little clearer. Okay, let me just turn this around. Okay, so let's have a look and see if we can get in a little bit closer to those numbers. Okay, so hopefully you can see those. Alright, so we're talking, what's that one? So that would be number 04, 05, 06, 07, 08, 09, 10, and you can see they're on the end of each line. Alright, and these numbers are called eastings. Alright, and each easting is connected to the lines that are vertical, that go straight up and down, run from south to north, or from north to south. Okay, all the vertical lines, vertical means straight up and down. Going along to the left-hand side of the map, we have the northing numbers, what we call northings. Okay, and the northings start from here. That would be number 30, number 31, number 32, number 33, number 34, and so on. They would carry on going up to the top of the map, to the northern top of the map. So these are called northings. They always go up, and they always increase by value or by number going upwards. Each of the northing numbers are connected to the grid lines, what we call grid lines, these grid lines again, okay, and these grid lines here are horizontal, that go across the map, okay, so they go across the map that way. Alright, another one there going across, another one here going across, okay, so all the northing lines, these northing grid lines run horizontal, okay, going from west to east or east to west, as long as you know that they're horizontal, they're the flat ones. Okay, so we've got our northings numbers, and our northing numbers go straight up, and our northing lines go horizontal, that are connected to those numbers. Our easting numbers go from west to east, right? And our easterly numbers are connected to the lines that